Hey guys, it's Miss Walker here. Happy day 2 of pre-cal. This should be a review because we graphed ellipses before spring break, so let's just jump right in. Just remember that your A and your B describe how the ellipse is stretched horizontally or vertically. So if you see A squared, if you see your big number underneath the X, it's horizontal, and if you see your big number under the Y, it's vertical. So that's step 1. The third formula here to remember is for your foci, or your foci is the correct way to say it. C squared is equal to A squared minus B squared. All right, so that formula will come into play in a second. All right, guys, so first things first, we see that our big number is underneath the X, so this tells us that it's going to be a horizontal ellipse, okay? Next up, you want to find your A, your B, and your C. Okay, and just remember that for the vertices, that uses the A, the co-vertices is your B, and your foci is your C. All right, so if we have A squared of 36, to take the square root of that, that gives us 6. If our B squared is 9, then it means B is 3. And then to find the C value, remember it's A squared minus B squared. So you've got 36 minus 9 gives you C squared. So you get 27. Take the square root of that. And if you wanted to simplify that radical, it gives you 3 root 3. Or it's approximately 5.2, which will come into play when you graph it. Okay? So next up is the center. Just like circles, make sure you change the sign. So it's 5, positive 1. The vertices, since the A squared is underneath the X, the A is going to affect the X value of the center. So we're going to take this 6 and we're going to add and subtract it to 5. So 5 minus 6 is negative 1. And 5 plus 6 is 11. All right, since the B squared is underneath the Y, the co-vertices are going to affect the Y value of the center. So we're going to take 3 and we're going to add and subtract it to 1. So you get 5, negative 2, and you get 5, 4. Okay, the foci and the vertices are best friends. So wherever the vertices are, the foci is along that axis as well. So since the vertices affected the x-coordinate, so are the foci. So it's going to be 5 plus or minus 3 root 3, comma 1. Eccentricity is just a formula. C divided by A. Your C value is 3 root 3, and your A is 6. Just make sure you simplify that. Square root of 3 over 2. Finally, your major axis is 2 times A, and your minor axis is 2 times B. So 2 times 6 is just 12, and 2 times 3 gives you 6. All right, those will also be proven once you've graphed it too. So let's go ahead and plot these points. We've got 5, 1, which is our center of our ellipse right there. Our vertices are at negative 1, 1, and 11, 1. So that's my vertice, that's my vertice. My co-vertices are at 5, negative 2, and they are at 5, 4. Okay, and notice right along here, that's my minor axis. So 1, 2, 3, 4, 5, 6. Yep, look at that, we're good to go. And our major axis all the way across would be 12. So we're right on. The only other thing that you're missing is that foci. So they always fall inside the ellipse. And like I said, they follow the vertices wherever they go. So we're going to go from 5. And at this point, it might be helpful to use that 5.2. So you add 5.2. 1, 2, 3, 4, 5.2 there. That's a foci. And then 1, 2, 3, 4, 5.2. So like right there is a foci. All right, and now we plot a perfect ellipse, and we are done. Okay, so it would be opposite if it was a vertical ellipse because your big number would be under the Y. Cool, all right, and finally, Next question, this says put the ellipse in standard form. If you want extra practice to graph it, feel free to graph once we get done. So just like we did in yesterday's video, you're going to group your x's, leave a little bit of room. You're going to group your y's, leave a little bit of room, and make sure you move that constant to the other side. We're going to look for a greatest common factor in each of these groups. So over here we have a 9 in common, so factor that out. And in our y's we have a 4 in common, so factor that out. All right, now we complete the square. So you take your middle term, you divide it by 2, and you square it, which gives us 4. Remember, you can't just add in numbers anytime you feel like it. So if you add in a number to one side, you have to add it into the other. But wait, don't forget about multiplying by that GCF. So 9 times 4 gives you 36. Same thing for my y's. You take that middle term, -6, divide it by 2, and square it, which gives you 9. And again, we didn't just add in 9, we added in 4 times 9, which is 36. Next step, we're ready to factor. So remember the little shortcut? You can just take that middle term and divide it by 2. Same thing over here. We're factoring this trinomial, which would be y minus 3 squared. Let's clean this side up a little bit. We add it all together. That cancels and we're left with 36. There's something about this that's a little weird, right? Ellipses always equal 1. So in order to get that to be equal to 1, we have a final step here of dividing everything by 36. Simplify it for me, and you get x plus 2 squared over 4 plus y minus 3 squared over 9 is equal to 1. Okay, and if you wanted extra practice, you could graph this on your own. Cool. All right, guys, I hope you're ready for some practice. Sorry for the messy handwriting. It's very difficult to write on these laptops. All right, good luck on the homework. Bye.